Hello students, today we are starting assignment 7.1. In this assignment, we have expression for current in different AC circuits, and we will also compare current with uh, voltage. When voltage changes, what is the response of current? Is it changing correspondingly or it is changing in different manner? So there are 5 questions and we will address these 5 questions in 4 different videos. In this video, we'll see first 2 questions, then next video third question, fourth one will be addressed in separate video, and for fifth question, we'll have last video of assignment 7.1. So first video, second one, third and fourth. Okay, so let us start first video of assignment 7.1. The question here is first question, write expression for capacitive reactance, inductive reactance, write their units and dimensional formula. So earlier in previous video of prerequisite, we already had seen that capacitive reactance, the way we have resistance R, the effect of capacitance is measured in terms of capacitive reactance denoted by XC, and its expression is 1 by omega C. What is omega? Angular frequency of AC source. So if the coil between two magnets is rotating fast, omega will be more. If omega is more, XC will be less. Secondly, if you take capacitor of higher capacity, then also you can minimize XC. More the XC, more is the hindrance to current, or you can say you can control current by increasing XC. Similarly, for inductor, the parameter is XL, which is given as omega L. Okay, omega L determines how much is the influence of inductor on current passing through AC circuit. But both these parameters are applicable for AC circuit only. If you have DC source, then these two parameters have no significance, no role to play. Okay, and what is unit of XC? Ohm. XL is also measured in terms of ohm only. How to find out dimensional formula? I leave it to you. Figure out. Okay, easy exercise. Second question is, write expression for complex current for AC circuit with resistance only. AC circuit and resistance only. Let us go to that. So I have a resistor connected with a source of alternating voltage. Now alternating voltage is the one where polarity is changing. So if this is the graph of voltage versus time, the voltage must be function of sine or cos. Okay, for now we take function of sine, so I take V as Vm sine omega t, and then the voltage can be represented as you should be careful about certain things when you are plotting graph. Whatever is the maximum value here, same should be maximum value here, and it is Vm in this case. Okay, and this is one cycle, so I can say that this time period is t, and this is this is t by 2 half time period. Okay, so this is the nature of voltage, and the component we have connected is R. But as R is ohmic component, I can write V is equal to IR. As it is AC circuit, the current is denoted by small I, and as it is AC circuit, you should not show positive negative here. Okay, if you show positive negative, it is wrong thing, because in alternating source, polarity is continuously changed. So now, if I make I subject of formula, I is equal to V by R, hence I is Vm sine omega t. upon R. You can write it as I is equal to Vm by R into sine omega t. Now, as Vm and R both are constant, you can replace two constant with single one, and then it is Im sine omega t. So, suppose if V is 5 sine omega t and the resistance in your circuit is say 2 ohm, then Im becomes 5 by 2. Okay, so then equation is 2.5 sine omega t. So that is Im, and then the current equation is I is equal to Im sine omega t. Now compare these two equations. V is equal to Vm sine omega t and I is equal to Im sine omega t. So both are function of sine. The difference is the maximum value of voltage is Vm, whereas maximum value of current is Im, but both are function of sine. And what is the phase of voltage? Omega t. What is phase of current? That also is omega t. It means that when I plot current on this graph, the phase must be same. So starting point must be same. It's just that as the maximum value of current is Vm by R, the peak value should be less. Okay. And then I can represent current like this. Notice that the zeros of voltage and current are same. Okay, where when voltage becomes zero, current is also being zero at the same time. When voltage is arriving at its peak, current is also reaching its maximum value. Okay, check all these points. So we say that voltage and current both are in phase. They are going up and down together. And what is the maximum value of current? It is Im. What is Im? Vm by R. Okay, this is the maximum value of current. So this is the nature of current in a circuit where you have only resistor connected with source of alternating voltage. Now, what is the essential part here that you should not forget, that V is Vm sin omega t and current I is Im sin omega t. One more thing I would like to highlight here, it is not necessary that voltage is always function of sine, it can be function of cos also. If voltage is function of cos, current will also be function of cos. Okay, what is Im? Maximum value of voltage divided by R. So that is all for this circuit and this video. We'll address the next question in next video. Thank you.